Welcome to the Deep Dive. We're your shortcut to understanding the big shifts in tech and, well, beyond. Today, we're looking at something that feels genuinely significant, a major strategic pivot from OpenAI. Yeah, the company literally called OpenAI. Seems like they're making a big move back towards that idea. Our mission for you today, we want to unpack their recent release of these gpt-oss models. We'll explore what open weights really means, why it's a game changer for things like accessibility, privacy, cost, and crucially, how you can actually get started with them.
It really is a fascinating moment.
Mm-hmm.
August 5th, 2025. That's when they launched gpt-oss 120B and gpt-oss 20B. And this isn't just, another minor release. These are their first open-weight large language models since GPT-2, way back in 2019. So yeah, it really signals a seismic shift in their strategy, making these state-of-the-art reasoning models available under the Apache 2.0 license. That's huge for the open community. It's a fundamental change, really, in how they're engaging with the whole AI ecosystem.
Okay, so let's break down that core concept first, because I think it's super important for everyone listening. When we say open weights, what exactly are we talking about? And maybe just as important, how is that different from what people might think of as fully open source? They get mixed up, right?
That's a really good question. And yeah, there's often confusion there. So open weights means the final trained parameters,
Yeah.
the weights and biases, the numbers the model learned are public. You can download them. You can run them on your own gear, use them. But, and this is the key difference, unlike true open source, you typically don't get the full training code or the original data sets or the entire development pipeline, maybe not all the intermediate checkpoints. Andre Carpathy had a great analogy for this. He said it's like getting the binary for an operating system.
Right.
You get the powerful end product, the executable, but not necessarily all the source code, the raw ingredients, or the recipe that created it.
Right, the executable versus the source code, that clarifies it nicely. So, okay, understanding that distinction, what does this actually mean for you listening right now? In practical terms, why should someone care about open weights if they're just looking to use AI, maybe beyond simple API calls?
Well, if you connect the dots, the benefits are pretty substantial. They directly impact how you can innovate and deploy AI. First off, you get accessibility and control, big time. You can run these models, tweak them, deploy them, without being locked into API fees forever. No vendor lock-in. And that's not just about saving money on existing stuff. It really democratizes AI development. Think about niche applications that were maybe too pricey before, or totally new business ideas that just weren't feasible with per token costs. It really lowers the barrier to entry. That's a whole long tail of specialized AI solutions pop up. Second, and this is critical, privacy. For anything sensitive, healthcare data, financial records, government stuff, your data never ever has to leave your own servers. Your infrastructure, that's a massive win for compliance, for security. But it also just fundamentally shifts the trust equation. Imagine doing sensitive medical research or analyzing confidential financial reports with powerful AI. But without ever sending that proprietary data out to a third party, it could really speed up innovation in those regulated fields. Third, you get amazing customization. You can fine-tune these models specifically for your needs, your use case, without pushing proprietary data through someone else's API, which also ties into cost efficiency. Once you've made the hardware investment, right, there are no ongoing per-token charges eating away at your budget. And finally, maybe the broadest impact. It's an innovation catalyst. It just enables research, experimentation, collaboration within the whole community on a scale that wasn't really possible when everything powerful is behind an API wall.
So it's really moving from just renting AI capabilities to genuinely owning and controlling them. That sounds incredibly powerful. But of course, an open weight strategy is only as good as the models themselves. So who are these new players? What are the specifics of the gpt-oss models OpenAI actually released? And how are they tailored for, different needs and, importantly, different hardware budgets?
Right, good question. Let's start with the big one, gpt-oss 120B. This is the powerhouse, and has 117 billion total parameters. But importantly, only about 5.1 billion are active at any one time. It uses that mixture of experts architecture, MoE. What MoE means for you, listening, is that the model has lots of specialized expert subnetworks, and it smartly activates only a few relevant ones for any given task. So it's super efficient despite its massive total size. This model is designed to run well on a single 80GB GPU. Think an NVIDIA H100 or similar. And performance-wise, it's getting close to OpenAI's own proprietary 4-mini model on key reasoning benchmarks. That's pretty impressive. Architecture details, 36 layers, 128 experts per layer, and it uses 4 active experts for any input. This one's really for your complex, high-stakes reasoning tasks. Advanced coding, summarizing multiple long documents, that kind of thing. Then there's gpt-oss 20B. This is really positioned as the efficient choice. It's much smaller. 21 billion total parameters, 3.6 billion active. Again, using MoE. And what's really remarkable here, I think, is that it can run on just a 16 GB GPU or even unified memory, much more accessible.
Yet its performance apparently matches OpenAI's O3 mini model, even though it's 6 times smaller in active parameters. This one has 24 layers, 32 experts per layer, also using 4 active experts. So if you need powerful AI, but you're working with more modest hardware or thinking about mobile or edge deployments, this is probably your go-to.
Wow, packing that much performance into the smaller model is quite something. So, okay, size and performance profiles differ, but do they share common features, things that make both models versatile across different applications?
Yes, absolutely. They share several really powerful characteristics. Both models boast a huge 128,000 token context window.
128K, that's massive.
It is. To put that in perspective, that's roughly, 250 to 300 pages of text that the model can process and understand all at once. Incredible for long documents, complex reports, or just having really extended conversations. They both use the standard transformer architecture, but with that efficient mixture of experts design we talked about. And for efficiency, they come with native MXFP4 quantization. Basically, they run using about 4.25 bits per parameter. What that means for you is these powerful models need significantly less memory and compute power to run. It makes them surprisingly accessible, even on less extreme hardware. It's a direct win for, your budget, your energy consumption. Really smart engineering. They also offer flexible reasoning modes, low, medium, and high effort levels, so you can trade off performance versus compute cost. And they come with native tools baked right in: web browsing, Python code execution, and pretty robust function calling.
That large context window and the built-in tools, that definitely makes them sound ready for complex tasks out of the box. But, benchmarks aren't always the whole picture in the real world. We know that. Still, how do they stack up on those standard tests? What do the numbers tell us about their capabilities?
Yeah, benchmarks always need context, but the scores here are strong across the board. They've tested them rigorously on things like MMLU, that's for broad language understanding, code forces for coding, and Health Bench for medical reasoning. And the results consistently show they're getting very close to parity with established proprietary models, which, for open-weight releases, is actually a pretty big deal. It suggests they're genuinely ready for complex, real-world work.
Okay, so we've covered the what these new models and the why this significant shift back towards open. But for a lot of you listening, the big question now is probably, okay, great. How do I actually get my hands on these? How do I start using them? And what kind of industry reaction are we seeing already?
Right, let's get practical. Hardware first. For gpt-oss 20B, the smaller one, you need at least 16 GB of VRAM or system RAM, manageable for some high-end consumer setups or workstations. For the gpt-oss 120B powerhouse, though, 80 GB of VRAM is recommended. That typically means a single H100 GPU or something equivalent, which, let's be real, isn't exactly standard consumer kit for most people. So you might be looking at cloud instances or specialized hardware there.
Okay.
And storage-wise, you'll need somewhere between 20 and 50 gigabytes just for the model weights themselves. Now, for actually getting started, you've got a few main options depending on your setup and comfort level. Option 1, Llama. It's probably the easiest way, especially for consumer hardware or just trying things out quickly. Super straightforward. You install Llama, often with just a simple curl command in your terminal. Then you can literally just type llama run gpt-oss.20b or llama run gpt-oss.120b. It pulls the model and runs it. Great for experimenting on your laptop.
Nice and simple.
Option 2, VLLM. This is geared more towards server deployments, production environments, places where you need high throughput, efficient serving. You can install VLM with GPT-oss support, usually via pip, the Python package manager. And then it's pretty easy to start up an API server that's compatible with OpenAI's own API format. So you can integrate it into existing apps quite smoothly.
Okay, for more serious use.
Exactly. And option 3, direct from Hugging Face. If you want maximum control or you have a specific custom deployment in mind, you can just download the model weights directly. Use the Hugging Face client download command to grab the OpenAI 20VB or OpenAI 120B model, so you get all the original files right on your local machine.
That seems like a good range of options, from easy experimenting to full production control. You mentioned earlier the industry reaction seems significant. What about the partnerships? Who's already supporting these models?
Yeah, the partner list for the launch was extensive. It really speaks volumes about how much demand there was for something like this.
Yeah.
OpenAI clearly collaborated with a lot of leading platforms to ensure day one availability. On the cloud side, you've got AWS, Azure, Databricks, Bayton, all major players.
Yeah.
For inference platforms, tools to help you run the models efficiently, you see VLLM, Llama, LM Studio, Together AI, Fireworks, all on board immediately. Hardware giants too, NVIDIA, AMD, Cerebras, Grok. They're providing optimized ways to run these models on their specific chips.
Right.
And maybe most tellingly, you have early enterprise adopters, companies like AI Sweden, Orange, Snowflake. These are serious organizations, some in regulated industries, showing immediate interest in using these models in the real world.
That is a comprehensive list. What does that immediate broad adoption really tell us about the industry's maybe readiness for open weights? Does it signal a bigger shift, perhaps?
I think it absolutely does. It signals a profound shift, really. Industry seems ready, even eager, to embrace self-hosted, customizable AI for a lot of use cases, moving beyond just relying on centralized APIs. The biggest challenge, of course, will likely be managing the infrastructure and, frankly, the expertise needed, especially for smaller teams or companies.
Sure.
But that's where this robust ecosystem of partners comes in, right?
Yeah.
They aim to make it easier to deploy and manage these models.
Makes sense. So with all these partners and this clear interest, what are some of the actual real-world applications people are already building or exploring? How is this becoming relevant across different fields? You mentioned startups, government.
Yeah, it's fascinating to see how quickly people are putting them to work. And it really spans a wide spectrum. We're seeing immediate use for on-premises deployments, specifically to meet data security and compliance rules. People are doing custom fine-tuning on their own specialized data sets, crucially without having to send that data externally. And of course, cost optimization. Just replacing expensive API calls with local inference is a big driver for many. It's also enabling genuine privacy-first AI applications in those highly regulated sectors we talked about.
Okay, so give us some concrete examples.
Sure. Think about enterprise AI. Companies using it for internal knowledge bases, smarter customer support bots, document analysis, all running locally. In healthcare, you can see privacy-compliant medical reasoning tools, maybe assisting with diagnosis, running right inside a hospital's secure network. Financial services using it for secure analysis of sensitive documents, risk assessment, fraud detection, again, without data ever leaving their control. Research, obviously. Academics can experiment freely without worrying about usage limits or high costs. Startups can now integrate really powerful AI much more cost-effectively, potentially building entirely new products that weren't viable before. And critically, government. The ability to build sovereign AI. That means hosting and managing AI systems entirely within their own national borders, on their own infrastructure. That's huge for national security and data control.
Okay, so wrapping up our deep dive today, this really doesn't feel like just another model release from OpenAI. It seems like a major strategic redirection, a genuine return to that open philosophy they started with. It's pushing towards more accessibility, more customization, the freedom to self-host, all under that permissive Apache 2.0 license. It honestly feels like it unlocks a whole new set of possibilities for anyone out there looking to build with AI or even just understand it better.
Exactly. You now have this clear choice. The powerhouse GPT-oss 120B, if you've got the 80 GB GPU and need that top-tier reasoning. Or the incredibly efficient GPT-oss 20B running on just 16 GB of memory, but still punching way above its weight, matching larger proprietary models. And both are proven performers, right? Strong benchmarks suggest they're ready for real work, straight out of the box. Your journey, if you're listening, your journey of discovery and applying AI just got a whole lot more interesting and definitely more accessible.
A really exciting development to watch unfold.
Absolutely. And it makes you wonder, doesn't it? Given this big pivot towards open weights, the focus on self-hosting, on privacy, what kinds of new innovation might this unlock? Maybe decentralized AI, highly specialized models for niche domains, things that just weren't practical or even possible with purely API-driven models. What stands out to you, listening, as the most transformative part of this whole strategic shift? Something to think about.